Hello everyone! Today, we are mastering coordinates by solving 3 classic 11 plus exam challenges. Let's start with question 1. 3 corners of a parallelogram are at A, -3, 1, B, 2, 1, and C, 0, -3. We need to find the 4th corner, D. Let's plot our known corners on the grid first. Here are A, B, and C. A very common mistake is to just eyeball it and guess the coordinates, drawing a point at -4, -3 to complete a shape. But look! That shape is wonky, and the sides are not parallel. That's definitely incorrect, so let's cross it out. Instead, we must use the parallel jump rule. Look at the top side of our parallelogram from B to A. To get from B at x-coordinate 2 to A at x-coordinate -3, we jump left by 5 steps. Since opposite sides of a parallelogram must be equal and parallel, we must make the exact same jump to get from C to our missing corner D. Start at C, which has an x-coordinate of 0, and jump left by 5 steps. 0 minus 5 gives us -5. Since this is a horizontal jump, our y-coordinate stays the same at -3. This places corner D at coordinates -5, -3. Let's write down these steps. To practice questions like these and find out exactly what your child really needs to focus on, why not try our free adaptive diagnostic test? You can find the link in the description below. P is located at -2, 4. We need to reflect point P in the horizontal mirror line, y equals 1. Let's draw our grid, plot point P, and draw our mirror line. A common trap is to reflect across the main x-axis instead, which is at y equals 0. That would mistakenly place the reflection at -2, -4. But look! Our mirror line is at y equals 1, not the x-axis. So that guess is incorrect. Let's cross it out. To reflect correctly, we use the mirror jumps rule. Count the vertical steps from point P at y equals 4, down to the mirror line at y equals 1. That is a jump of 3 steps down. Now we must jump the exact same distance of 3 steps down from the mirror line to find our reflected point. 1 minus 3 steps brings us to y equals -2. Since this is a vertical reflection, the x-coordinate stays exactly the same at -2. This places our reflected point P' at -2, -2. Let's write down the calculations. And finally, question 3. A rectangle is drawn on a blank grid with no grid lines. We only know 2 opposite corners, A at 2, 3, and C at 8, 7. We need to find the coordinates of the center. Let's sketch our rectangle with corners A and C first. Before finding the middle, we can easily find the other 2 corners by sharing addresses. The bottom right corner, B, lies directly to the right of A, so it shares A's y-coordinate, 3, and directly below C, sharing C's x-coordinate, 8. So B is at 8, 3. Similarly, the top left corner, D, is at 2, 7. A common mistake is to think we can find the center by just dividing the top right coordinates by 2, which would give 4, 3.5. But look! 4, 3.5 is way off towards the bottom left, not in the center of the shape. So that guess is incorrect. Let's cross it out. To find the exact center, we use the middle meeting rule. Let's look horizontally first. The width of our rectangle goes from x-coordinate 2 to 8. That is a total distance of 6 steps. Half of 6 is 3 steps. Starting from 2 and jumping 3 steps right, brings us to a middle x-coordinate of 5. Now let's do the same vertically. The height goes from y-coordinate 3 to 7. That is a total distance of 4 steps. Half of 4 is 2 steps. Starting from 3 and jumping 2 steps up, brings us to a middle y-coordinate of 5. Combining these together gives us the center coordinates, 5, 5. Brilliant job! Let's recap the 3 key rules we used today. First, the parallel jump rule. Opposite sides of a parallelogram share the exact same horizontal and vertical jumps. Second, the mirror jumps rule. Reflected points are always the same distance from the mirror line. And third, the middle meeting rule. To find the center of a rectangle, find half the width and half the height. Then add those to your starting corner. Remember these, and coordinate questions will be a breeze. Give yourselves a huge pat on the back. For more practice on coordinates and other Key 11+ topics, head over to cognaris.uk. I'll see you in the next lesson.